Hey guys, welcome to another episode about ESP microcontroller programming. In this episode I'm going to teach you how to use this RGB diode. And this particular RGB diode has 4 pins. First pin is for red color, second pin it's common ground because this is common cathode diode. Third pin it's for green color, and fourth pin is for blue color. And as I said, this particular diode is common cathode, and if you are not sure whether your diode it's common anode or common cathode, I have a special episode just for that. Link is going to be somewhere in the corner. And on the right side we have a Node MCU ESP32 microcontroller. Everything is set. I just need to hook up my RGB diode in here. Alright, we already have some colors. So what we have in here, with orange wire I have connected common ground from RGB diode to the ground on this microcontroller. With yellow wire I have connected through this 220 ohms resistor, red pin from our diode to pin 23 on our microcontroller. With green wire we have connected green color from our RGB diode to pin 22, and with white wire we have connected a blue color from RGB diode to pin 21 on our microcontroller. And don't forget that we used this 220 ohms resistor for every color in order to reduce current. Finally, I'm going to transfer this video to my screen in order to show you how we are going to deal with the code. Hey guys, first I have to make some brief explanation of what we are going to do in here. I want to create code that is going to allow us to change color in real time. So we are going to have communication part, and we are going to have a part for color changing. But this is not going to be simple task because we are not dealing with analog but with digital pins. So instead of using voltage to set color, we are going to use pulses. And how is that going to work? If, for example, we want our color to be 20% red, 20% blue and 20% green, that means that all of 3 pins need to be turned on 20% of time, equally spread through time unit. So if we observe one time unit that contains 100 smaller time units, that means that we want our pins to be turned on in 20 of those 100 units. But of course evenly spread in order to get the best effect. So what we need from our code? First we need 3 integers. R is going to be on pin 23, this is for red color. Green is going to be on pin 22, and blue is going to be on pin 21. Now we need 3 arrays that are going to be used in order to store states. So those are going to be of bool type, RP for red pulses, and we need 100 of them. I'm going to copy this part. So we need red pulses, green pulses and blue pulses. Now we need 3 more integers that are going to store value in between 0 and 100, and we are going to use those in order to define how much of every color in percentage our final color is going to have. So we are going to have int for RC, stands for R counter, let's say 10%. Another is going to be green counter, let's say 70%, and finally blue counter, let's say 90%. We need another integer, I'm going to call it counter, set it to 0. This counter is going to be used in order to iterate through this bigger time unit that contains these 100 smaller units. And we need 3 voids. Void communicate, void clear state, and void calculate pulse. So of course we are going to use this first void to deal with communication. With this second void we are going to clear states from these three arrays. So we are going to use it to set everything to false. And with calculate pulse we are going to deal with arrangement of these pulses. So in void setup, first thing that I'm going to do, I'm going to set pin modes for all of these three pins. All of them is going to be output. And I'm just going to copy this. All right. And I'm going to write low to every single one of them. Of course, I'm going to copy it. And in here I could call a function clear state. Don't worry, we are going to write body of this function in a moment. And now we are going to start our serial communication with baud rate of 9600, and that is all for void setup. So now I'm going to write body for this clear state function. So in here I'm going to use for loop, red pulses with index I set to false. I'm just going to copy this, both for green pulses and blue pulses. So this is fine. And now I'm going to get back to this void loop. So now if counter equals 0. Why is this loop for? So when we end a sequence of 100 time units, I'm going to repeat entire code from the beginning. So at the end of this void loop, I am going to write another code. So if counter less than 100, counter plus equals 1. So we are going to add value of 1 with every iteration. Else counter is going to be set to 0. And in this loop, first thing that we are going to do, we are going to communicate. Second thing, we are going to clear state. And third, we are going to calculate pulse. Now, when all of that is done, we are going to perform turning on and turning off. So we are going to execute this code. So our pulses, index of counter, if that is equal to true, then we are going to perform digital write of pin R to high. Else I'm going to copy this code, but in other case we are going to set it to low, like this. And I'm going to copy this entire line twice. All right. In this second one we are going to deal with green pulses, and in here we are going to deal with blue pulses. So in here green, green, blue, and blue. And now I'm going to write body of calculate pulse function. Let's go down. So void calculate pulse, no arguments. Make some spacing here. So first thing in here, we need to create three floats. Float RJ, short for RJump, that is going to be 100 divided by float of R counter. So why is this number important? If, for example, your R counter is 10, meaning you want 10% of red color. In this case, RJ is going to be 10. That is useful because we want on every 10th iteration our red pin to be set to high. And we are going to do exactly the same for all of 3 colors. Just we are going to change these names to blue jump and green jump. Oh, sorry. First it's green and then blue. And in here, green counter and blue counter. And now we need another float like this. Call it F. And I'm going to set it to 0. Now while loop. While F is less than 100. Don't worry, I'm going to explain everything in a moment. Now I need integer, call it RFI for red frequency integer, and I'm going to set value to F but cast it to integer. And now with R pulses, index of RFI, I want to set to true, and I want to add to value of frequency this number of red jump. So what this piece of code actually means? First we are creating this float variable and I name it F for frequency and we set it to 0. Now with while loop we are going to end this loop if F step over 100. So in first line in here I have created integer RFI, and this integer is going to be integer value of this frequency. So for example, if frequency is 4.25, we are going to get 4 value for RFI. And then element with index of RFI in array of red pulses is going to be set to true. At the end, we are appending a value of this R jump to a frequency. So think about this, what this actually means. Let's say that you want to have 10% of red color. That means that this RJ red jump is going to be of value 10. In this case, in first iteration, we are going to get frequency of 0. That means that RFI is going to be 0 too, which means that first element of R pulses is going to be set to true, which means that in first iteration every single pin is turned on, and then we are appending value of 10 to the frequency. Now in this case frequency is still less than 100, and now RFI is going to be 10. That means that next element RFI 10 is going to be set to true in this array of R pulses. And of course we are appending another 10. That means that every 10th element of this R pulses array is going to be set to true. In this way we are setting our value of 10% evenly across these 100 elements. But with R counter value of 10, this is not really interesting. I'm going to show you this next example. I'm going to copy this piece of code. And of course we don't need declaration in here, just F set to 0. And now instead of RFI we are going to deal with green color, and green jump. So now in this case with green color we have green color set to 70, meaning we want 70% of green color presence. Now I'm going to bring my calculator, and what I want to do is to calculate a value for this green jump. So we are going to divide 100 by 70 and we are going to get 142. What this actually means in this case? So our frequency is going to start with 0. So our GFI in first iteration is going to be 0. So we are going to set 0 element of green pulses to true. And of course we are going to append green jump to our frequency. So in second iteration our GFI is going to be 1. Because when you turn 1.22 to integer, we are going to get 1. That means that first element, meaning second element, so green pulses with index of 1 is going to be set to true also. And then we are going to append another green jump. So if I multiply this by 2, I'm going to get 285. So in third iteration, we are going to get value of 2 for GFI. That means that green pulse element with index of 2 is also going to be true. And we are going to append another green jump. But when that happens, so I'm going to add 1.42, we are going to get 427. What this actually means? We have first index set to true, second index set to true, and now fourth index set to true, but only third index it's not. So in this way we are evenly spreading percentage through this array. And of course I'm going to do this exact the same process for blue color. We are just going to change names. Blue frequency integer, then blue pulses, blue frequency integer, and blue jump. All right, this looks fine. And finally, we need to create a body of this communicate function. And we called our communicate function in here. I'm going to go to the end. So void communicate. All right, so first I'm going to use this while loop, serial, available, greater than 0, open this loop. I'm going to make some space. All right, so I'm going to use the read string function for this case. String str, it's serial read string. Okay, now we are going to trim it. Str trim. And in what form I want to send my command? I want to send 3 numbers for 3 different colors separated by space. That means that this str is going to contain strings like this: 10, 58, 69. So for that purpose we are going to split this string into 3 parts. I'm going to need character pointer. Also I'm going to need the length of this string. Call it L. Str length. All right. I'm going to create characters array with L number of elements, then nullify everything. All right. Now I'm going to copy content of this string to my character array with strcpy s and strc underscore str. All right. So with this code we turned our string into character array, and we have to do that in order to use strtalk function. So my pointer is going to be strtalk for character array s, and we are going to split it by space. And I need another character pointer. Let's call it ptr. So now I'm going to set r counter to be strtalk from this p pointer, and I also need this address of ptr, and base is going to be 10. So this function is going to turn a string value, meaning string representation of our number, into actual number, and I'm going to send that number to variable r counter, red counter. And in this way we are going to set another value for our red color. Now I'm going to ask for another element from this string with strtalk. Now we are going to provide null as first argument and empty string. Another is green counter, and we are going to use this very same function. But sorry, this is not strtalk, it's strtol. str12 function, it's for converting from string to integer. All right. And now I'm going to copy this code for blue color. This is fine. And now blue counter, and this other part is also fine. So I guess that this is done. I'm going to clear these empty spaces. We don't need this calculator anymore. And now finally I could upload this code and we could test it. So I'm pressing flash button on my microcontroller and I'm going to upload this code now. I hope that we don't have any typos. Let me check my serial monitor. I'm going to press flash once again. And let me send 3 numbers. So 25 space 50 space and 30. Well, now you cannot see that, but color on my LED diode has changed. And the next part of this video I'm going to record with my camera so you could see final result. So guys, now you can see both screen and my microcontroller. And now I'm going to send another command to my serial monitor. And I'm going to ask for red color, so 100 space 0 space 0. If I send this command, you see color changed to a red. And let's try something else. Now I'm going to send 0, 100 and 50. So we have another color. Let's try something else. 100, 0, 100. And we have purple. So guys, this is all for this episode. Thank you for watching. I hope that you have learned something interesting. So please like, subscribe and see ya!